Hello everyone, today's presentation is going to be about how you can use this building information model data to actually get to places with it. Just to do a quick recap, I'll mainly be talking about Solibri today. The most important part here is that you are authoring in an appropriate BIM tool. You can use the BIM tool of your choice. We'll get to that later, but it is very important that you're building this little virtual building model, and thus you're building this model. More and more information is put into this central database that we can use to get to accurate information. The other part is the openness of this platform. It's very important to be able to use your own authoring tool, the one you understand and the one that suits you, and then you can just use the common language, which is IFC in our case. Then you can just use the common language to communicate between disciplines and between sets. And that's exactly what Solibri does. Solibri can take many IFC models and collate them into what we call the Federated Building Model. This federated building model then can be used to look at what is actually going to be built on site. So let's take a look at that. On the left-hand side here, you can see all the individual disciplines models going into the Solibri model or the federated building model. This federated building model then can be used to visualize what is going to be built on site. So to actually take a look at the building as it is to be built, it can contain the architectural model, the structural elements from the structural engineer, and ventilation and electrical plans from the building services engineers. We can then use Solibri to perform various checks and procedures on this federated building model. First of all, and what's the more technical part here, is that we can check whether the data that we have is actually correct. And that's what the integrity of all data stands for here. Because we're all technically speaking a foreign language with each other, think of Solibri as a sort of spell checker. You need to go and check that everyone has spoken the language correctly. Otherwise, you'll end up with inaccurate results once you're using this model to get information out of it. We can also use Solibri to perform various checks on this model. So once we have the federated model ready, we can not only check for technical issues within the model, but we can also check for design issues. For example, we can check whether we're meeting our maximum travel distances and these sorts of things. This is done using small rules, which we can then use to slot into each other, creating larger rules. So for example, if there was a legal requirement for every space, so for every room with a furnace above a certain design thermal output level to have 2 exits from, we can actually check for this on an automated level. Because first of all, we can check if there is a furnace in the room. Then we can go ahead and check whether this furnace is below or above the legal maximum allowed thermal output. And if we determine that this furnace is above the legal output, then we can go and check whether the space has 2 exits. And if it doesn't, we can simply flag this up and say that this space will need to have 2 exits. On top of all of this sits what we call the BIM collaboration format, or BCF for short. The BCF is a specifically developed tool for communicating construction issues from one of these federated models back to the individual disciplines. We can use the BFC file to describe the issue, attach a quick live screen view, so a live viewpoint of this issue, and we can also assign responsibilities, and that's very important, because what you don't want to do is amalgamate all these little models into one big model and then make changes on that model, because that way you'll lose the trackability of liability, and if the architect makes a change to the structural plan, he'll become liable for it. Instead, using BCF and IFC, we can maintain who's responsible for what parts, and only the architect can make changes to the architectural plans, for example. And on top of this, BCF is also element and location aware. So you can use BCF to actually tag up a particular element. So say that all these columns need changing, the BCF file that you send will know the columns, where they are in the project, and what way you were looking at them when you created the issue. And all these can then be communicated back to the originator of those columns, who can then open up their BCF file in their authoring tool of choice and see these issues in their native environment. Most major BIM authoring tools support BCF out of the box. Others can be made compliant by using free add-ons and plugins to work together with BCF. So let's actually take a look at Solibri. I've got Solibri running in the background here, so I'm just going to click to change over there. What you see is a federated building model. I have loaded the architectural plans that were originated using ArchiCAD by the architect, and I have loaded the ventilation model for the building, which is originated from Autodesk Revit MEP. These are coming from my building services engineer. So first of all, I can actually take a look at the building. I can take a look at what is going to be built on site. It's very easy to use Solibri to just simply poke around the building and get an idea of what is going to be built. So these are the ventilation plans for the building. I can also ask Solibri to put this in context for me. So I can go ahead and say that I'd like to see the ventilation plans in context. Not only is this a great tool to understand what is actually going to be built on site, but it's also a great problem finding tool this way as well. Because if you find something outrageously big, for example, a duct protruding through the facade, you'll be able to flag that up immediately and say that this needs to be fixed before we go on site. However, the real strength of Solibri is in checking against this model. What we can do in Solibri is go ahead and check for particular errors. I'm going to quickly run these checks. Here we go. And we can see what Solibri has found. Solibri has a traffic light system here, so red, amber, and yellow, and we can fail or pass one of these rules. These are used to help you classify the issue and decide what needs to be addressed first. Red issues are things that you should address before going on site. Then amber and yellow issues are less serious issues, which should ideally be addressed, but it can be survived if they're not. So let's take a look at what we actually have here. So first of all, I found an issue where there's intersections between the suspended ceiling and ductwork. This is nothing new under the sun. Everyone does clash detection nowadays, but it's still an important issue to find because it's relatively easy to find this in a virtual space. It's painless. You can assign the issue and send it back to the architect and the ventilation engineer to work on this together to find the problem. But imagine finding this out on site. Half your building is already standing, the ductwork is in, your contractor shows up with the suspended ceilings and finds that all the little hooks are too short. It will be detrimental to the project, and you'll need to sort it out on site, wasting money and time fixing an issue that you could just have found in a virtual space before you ever went on site. So in order to effectively communicate this issue, all I need to do is right-click on the issue and add what we call a slide. Each slide belongs to an individual issue, which we can then include information against. So first of all, a viewpoint is included in the slide. Like I said, this isn't just a dummy screenshot, this is an actual live viewpoint. You'll see that later on. We can also assign the responsible personnel against this issue. So we can go ahead and say that this is both the architect's and the ventilation engineer's responsibility, so both of them will need to take a look at this issue. And like I said, the BCF file is also aware of which elements are included in this problem, so we can see that these are the ducts included and these are the suspended ceilings that are included in these issues. Clicking OK, I can carry on. Let's take a look at a few more issues that we have located in this building model. This issue here is telling me that these spaces don't have enough windows. This is okay. This was an architectural decision we made early on. This is because this is the security space and the conference room. We don't want people snooping in on either on the ground floor, so we've decided to keep the window area small. This is okay, so I can just dismiss this, saying that this is not actually a problem. However, what Solibri has also picked up on is that these rooms have very large window areas. Now this is something that is specifically mentioned in building regulations. If you have a glazed area above a certain percentage of your floor area, you need to make sure that these windows meet the U values. So this is something that I send back to the architect for his consideration. I don't necessarily need to reject something. I can also include them as for information only, in which case it will be easy for the architect to understand what issues he needs to address first, and what issues can wait for a little to deal with. Another problem here that Solibri has picked up on is more of a buildability issue of the design. What we see is that the suspended ceilings are really close to the slab above. While this might not be a particular problem while constructing, and the building is definitely still buildable, however, this is something we should consider before going on site. Because if the contractor is having trouble fitting the suspended ceilings simply because his hands can't fit over the ceiling, it will slow him down, and we might fall out of schedule and our programming might get compromised. So we want to make sure that this is something that we know about, and maybe we'll be able to forego this issue before ever actually going on site. Again, this is something that belongs to the architect, so I'm just going to send this back to the architect as an issue. Let's carry on. The next one we see here is that these spaces in the building don't have a safe exit. So this space here, there is no safe exit from this room. This is okay. This is a pipe shaft, and you don't need to escape from a pipe shaft, so I can just again mark this problem as an accepted issue and carry on. The last thing I'm going to highlight is that we can't only check for things that are clashing or touch and they shouldn't. We can also check for issues where things are supposed to touch but they don't. What we see on screen here is that these columns don't actually meet up with the slab above. This can be a serious problem. Just imagine not finding this before going on site and finding this out when your precast concrete slab has arrived. The precast concrete slab arrives, gets craned up, and when you try to fit on the top of the building, you find that all these columns are 2 feet short. This will be detrimental to the project. It's wasteful, it will cost someone money and time to fix. However, because we find it in a virtual space, we can forego these design issues before they actually become a problem on site. So all we need to do is again add the slide against this issue and send this issue back to the architect to fix it. Now that I have assigned slides against all of these issues, I need to tell the people who are responsible for them. And the way to do this in BCF is to create what we call a presentation, and this is why each issue is called a slide. I can ask Solibri to automatically create a presentation from the checking results using those slides that I have just added. So all I need to do is ask Solibri to do that for me, and all these issues that I have highlighted are now available for me here, ready to go. Like I said, these are not just dummy screenshots. These are still interactable views of the model. This is a great tool to actually understand what the problem is. So instead of just looking at an image and the screenshot, the architect can actually go around the model, measure how much is missing, take a look at from the angle that's easy for him to understand of what's actually happening, and then actually address the issue. So to actually go and tell people this, all I need to do is create the BCF file. I can just report this out into BCF file. I'm just quickly going to save this on my desktop here. And all I need to do from here onwards is send this BCF file to my architect. VCF files are very small, they're easy to handle, so I can actually just email this file to the architect, and once I have, the architect is able to open this up in his authoring tool of choice and address the issues. So let's do exactly that. I've got this building running in the background here, using the same tools that have been used to author the buildings. So all I need to do is, using my native authoring environment, the one I like and the one I prefer, load this BCF file in and find every single issue. So here's the BCF file that I have just received from the project manager or whoever made the checks. And once I've imported this file, all these issues that have been highlighted are available to me in my native working environment. So here's the issue with the columns. So let's do that. Let's fix that one. Double clicking on the issue have actually selected all of these columns for me, which is actually a very important feature. Because think about it. If I just wrote you an email saying that these dozen columns on the top floor need to be extended 2 feet up, there is actually a good chance that you only select 11 and only change 11 columns, necessitating another round of issue fixing. However, if I just go ahead and fix the issue using the automated tools, I can be sure that I'm actually fixing all the elements that have been included in this problem, so I don't need to worry about actually having to find the columns. So let's do that. I'm just gonna go ahead and fix these columns. So here's the column, and all I need to do is extend the column so that it actually lines up where it's supposed to be. Here we go. Now that I have fixed this issue, I can actually mark it as a closed issue. This is no longer a problem, I fixed this. Now that I fixed this issue, I can send this back to the person who sent the problem to me, telling them that this is okay, I have fixed this. So all I need to do is send this file back, and we're done. After a few cycles of these checks, we can actually ensure that no major problems are present in the design, so we can proceed to actual construction stage with a peace of mind, knowing that no major design flaws will surface during construction. So just to quickly recap, we take models from all disciplines and combine them into what we call the federated model. We can then use rules to check against this federated model to locate design and technological use issues and fix them before they become an actual problem on site. We can then report these issues back to the appropriate personnel using BCF, making sure that we have an effective way of communicating these issues. It's a very nice thought to use a mouse to fix a problem instead of a jackhammer, because it costs less and it's easier. Just how much less does it actually cost? What we see here is the ratio of finding a problem and at what stage during the construction we discover this problem. Naturally, the easiest way to fix an issue is not to make it in the first place. That will be the planning stage. However, Solibri comes in at the design review stage. At design review, it will cost relatively little to fix a problem that we've located in the virtual building model. However, if we actually go on site and find this issue halfway through installation, it can cost 1,000 times more than it would have if we didn't make the error, or it will cost 100 times more if we've only located it during design review. God forbid you don't find this issue during construction process, you hand the building over, and then you get sued for this. Court costs can fly out of hand, it can completely get out of hand, and can be a major pain for everyone involved in the process. Thank you for your attention today.